Hi, I'm Camille Block. I'm a second year PhD student. So I study like a worldwide distribution of bed bugs, looking from a genomic perspective. So as you can see, we use a lot of various different molecular tools in the lab. I'm studying the different ways basically that humans impact bed bugs over time. I'm studying like socioeconomics, insecticide resistance, how things like human global travel have impacted bed bugs over the last 100 years.
And I'm Warren Booth. I'm an associate professor in entomology. And in my lab, we study how organisms adapt and evolve in the urban environment. And to do that, we use a mixture of genomic tools and chemical bioassays.
So we just published a paper, very exciting. So basically looking at the RDL, or resistance to D-eldrin insecticide resistance mutation. This is the point mutation in the bedbug genome that is thought to confer insecticide resistance, specifically to insecticides like fipronil. So I was able to use Sanger sequencing to look at that specific area of the bedbug genome and find if that mutation is there or not. And it was like my last 20 samples, and I found 2 instances of the RDL mutation for the first time in bedbugs.
The paper that Camille published is really interesting because it documents a new mutation. And that mutation is known in other indoor urban pest insects like German cockroaches. So therefore to find this mutation in bedbugs is actually really interesting because the insecticide that they're resistant to, or that this mutation confers resistance to, is not one that's used to treat bedbugs. It's used to treat dogs or your cat for tick or flea control. And therefore it's likely that bedbugs actually picked up this mutation or this resistance inadvertently because people co-sleep with their pets, and their pets have flea or tick treatments, and therefore that there is exposed any bed bugs that they might come into contact with to this insecticide resistance.